Hello students, we will be continuing with the numericals or the problems related to the topic electricity. So let's start with it. So by continuing the problems now. So a battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively. So how much current will flow through the 12 ohm resistor? So you will be putting the formula of resistors in series now. For resistors in series, R equivalent, resistor in equivalent equals to R1 plus R2 plus R3 plus R4 plus R5. You can see here. So it's substituting these values here. So you will be getting as 13.4 ohms. So now by Ohm's law, V is equal to IR. So continuing with, so substituting the values, 9 equals to 13.4 into I. So I is equal to 0.67 ampere. So here when resistors are connected in series, the current is same in all the resistors because the current that flows is in series, one resistance to others because it is connected continuously. So it will be the same. Hence current in 12 ohm resistor will also be the same. Answer as 0.67 ampere. So next, so we will go to the next question now. An electric heater of resistance 8 takes a current of 15 ampere from the main supply line. Calculate the rate at which heat is developed in the heater. So what is given here? Its resistance is given 8 ohms. So current is 15 ampere. Time is 1 second. So we know that by putting the formula H is equal to I square RT. So heat, they have asked heat, formula is H is equal to I square RT. So H is equal to, you will substitute 152 into 8 into, so I square. So 8 into 1, so it is 1800 joules per second. So continuing with next question. Which uses more energy? A 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes? So your power of TV, first we will write power of TV, P1 is 250 watts. So time taken by TV, that is T1 is equal to 1 hour. So it is 60 into 60 seconds, which is 3600 seconds. So power of toaster, we will write as P2, it is 1200 watts and time taken by toaster, we will represent it as T2 is 10 minutes. So it is 10 into 60 seconds, it is 600 seconds. So we will continue it. So now we know that what is power? Power is equal to energy by time. So we need to write the energy. Energy is equal to power into time. So first we will go with the TV set. So energy is equal to P1 into T1. So we will substitute the value here, 250 into 3600. So it is 9 lakh joules. So which is written as 9 into 10 to the power of 5 joules. So next coming to toaster. So energy is equal to P2 into T2. We have already got the answer for it. So it is 1200. We will substitute here. 1200 into 600. It is 7,20,000 joules, which is equal to 7.2 into 10 to the power of 5 joules. So while comparing here, which is going to consume more energy? It's the TV set. It is 9 into 10 to the power of 5 joules. So the energy consumed by TV is more. So we'll go to the next question. A hot plate of an electric oven connected to a 220 volt line has two resistance coils. So two resistance coils it has. It is represented as A and B, each of 24 ohm resistance. So A and B both have 24 ohm resistance, which may be used, it can be used separately in series or they can also be used in parallel. So what are the currents in these three cases? See, let's look at the solution now. The first case, so here each of the coil used separately. So each coil is used separately. So here resistance R is 24 ohms. So from Ohm's law, V is equal to IR, Ohm's law remains the same. So here V is equal to 220 volts, R is 24 ohms. So I is equal to 220 by 24, it is 9.17 ampere approximately. So when it is used in series, so series we can say it is total resistance R1 plus R2, that is 24 plus 24, it is 48 ohms. So therefore again we will substitute here in the Ohm's law, I is equal to 220 by 48, it is 4.58 ampere approximately. So when it is used in parallel, so total resistance is R1 in R2 by R1 plus R2. So you can see that 24 into 24 by 24 plus 24, it is equal to 12 ohms. So therefore the current is equal to 220 by 12, it is 18.33 ampere approximately. So let's see the next question. Which of the following terms does not represent electrical power in a circuit? So they have given the options here: I square R, IR square, VI, V square by R. So let's see the solution. So it's P is equal to VI, can be represented as equation 1. So hence the option C represents the power. So how it can be represented by power? Because V is equal to IR, volt is equal to current into resistance. So it can be represented by equation 2 from equation 1 and 2. So power is equal to I square R. So you can see that power is equal to I square R and power is equal to V square by R. So hence option A and D, so option A and D represents power 2. So option B does not represent the power. So they have asked the question that which does not represent the electrical power. So the option is B, IR square does not represent the power. So next question. An electric bulb is rated 220 volt and 100 watt. When it is operated on 110 volts, the power consumed will be. So let's see what will be the power consumed when it is operated in 110 volts. So let's write as power P is equal to V square by R and resistance equals to V square by P. So resistance can be, we can substitute here that 220 into, so V square is 220 into 220 by 100. So that is equal to 484 ohms. So here you can see that the current flow in the circuit I is equal to V dash by R. So V dash is the supplied voltage. The voltage supplied is given as V dash. So I is equal to 110 by 484. So that is equal to 0.2272 ampere. So the voltage drop across the bulb is 110 volts. The power consumed by the bulb can be represented by power of bulb is equal to V square by R. It is 110 into 110 by 484. So power of bulb is 25 watts. So next, two conducting wires of same material and of equal lengths and equal diameters are first connected in series. So these same material of equal length and equal diameter, they are connected first in series, then they are connected in parallel in a circuit across the same potential difference. So the ratio of heat produced in series and parallel combination has been asked. So let's see that heat produced in the circuit is inversely proportional to the resistance R. So it will be heat produced in the circuit. H is inversely, that is H is inversely proportional to the resistance R. So let resistance in series be equivalent to resistance of the wires if connected in series, and resistance in parallel will be equivalent to resistance of wires if it is connected in parallel. So next, so then what will be RS? Resistance in series, it can be written as R plus R, that is equal to 2R, and 1 by resistance in parallel is equal to 1 by R plus 1 by R, that is also can be written by 1 by Rp is equal to 2 by R, or it can also be written as resistance in parallel Rp is equal to R by 2. So now the ratio of heat produced can be given or is given by Hs by Hp is equal to V square by Rs into T by V square by Rp into T. So you can see here that these T gets cancelled and V square get cancelled. So it will be Rs by Rp, that is reciprocal, can be written as Rp by Rs, that is 1 by 4. So your answer is 1:4 is the ratio. So next, a copper wire has a diameter 0.5 mm and resistivity of 1.6 into 10 to the power of minus 8 ohm meter. So what will be the length of this wire to make its resistance as 10 ohm? So how much does the resistance change if the diameter is doubled? So if resistance how much is changed, that is diameter when it is doubled, then you can see that area of cross section of a wire, it can be written as A is equal to pi d by 2 whole square. So diameter is given as 0.5 mm, so it is written as 0.0005 meters. Resistance is R is given as 10 ohm. We know that R is equal to rho L by A. So L is equal to RA by rho. So that can be substitute here, 10 into 3.14 into 0.0005 by 2 whole square whole divided by 1 by 6 into 10 to the power of 4. So you can see that 10 into 3.14 into 25 by 4 into 1.6, that gives 122.72 meters. So next, you can see that here the length of the wire, we have got the answer as 122.72 meters. If the diameter of wire, they have asked that if it is doubled, new diameter will be 2 into 0.5, that is 1 mm, or it can be written as 0.001 meters. So let's see now the new resistance, which can be written as R dash. So it is R dash is equal to rho 1 by A. You can substitute here 1.6 into 10 to the power of minus 8 into the answer we have got the length of the wire 122.72 by rho, that is pi whole 1 by 2 into 10 to the power of minus 3 whole square. So it is 1.6 into 10 to the power of minus 8 into 122.72 into 4 by 3.14 into 10 to the power of minus 6. So your answer will be 250.2 into 10 to the power of minus 2. That gives rise to 2.5 ohms. So your new resistance is 2.5 ohms. So that's all about this topic or the numericals with respect to electricity. We'll continue in the next video.